I'm Mark Sponsler, and welcome to the Stormsurf Videos Surf Forecast for the week starting Sunday, April 11th. Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype. Looking at significant wave heights for the North Pacific Ocean, we don't see a whole lot going on. There's some wind swell generating seas off of Northern California, but that's about it. And you might ask, well, why are we still looking at the Northern Hemisphere? Well, it's because there's not a whole lot going on in the Southern Hemisphere. But pretty soon we will be transitioning and focusing down south as the North Pacific is pretty much done its thing. All right, let's move on. As usual, we'll start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when a gale does form, help direct their track. We're looking for a trough, that is a dip in the jet stream. There's sort of one right here over the north part of Japan. There's kind of something over here just about to push into Alaska, but no clear indications of any trough. But if there were a trough, it would help create a counterclockwise flow aloft and down to the ocean surface. And if that circulation is strong enough, it would generate winds, and winds, of course, generate seas. Seas generate swell as they radiate away from the fetch area, and swell, when it hits your beach, turns into surf. Unfortunately, we don't have anything in the North Pacific or the South Pacific doing any of that right now. We do have a pocket of winds, though, pretty strong, about 180 knots here off of east of North Japan, trying to get some traction, but notice the jet is split. The main flow comes off of Japan, splits here, we'll say north of Hawaii, with energy going pretty much nowhere. The northern branch trying to form a trough, but it not really doing anything. And in between these split flows, typically what you get is high pressure. And that's been the name of the game in the Gulf of Alaska since spring started. It seems like maybe in mid to late February. And strong high pressure here, especially amplified by La Nina, helps create north winds. North winds, if they blow and blow like what they've been doing, they create a lot of upwelling. Water temperatures down. Point Reyes buoy was 48 degrees 2 days ago. It's kind of bounced up now. It's almost 50, but still pretty cold. You need a thick wetsuit for sure surfing this time of year. All right, moving on. Let's go take a look and see what happens. So, not a whole lot of a change, but a trough is forecast Tuesday. You see it right there in the northwestern Gulf. Not a lot of wind feeding it, so there's not a lot of hope of anything developing too much from it. But then it gets a little bit better organized as we get into Wednesday. So we'll say maybe support for low pressure development, not even a gale. And then as you get into Thursday, look at this pretty healthy flow of winds pushing south, so that would help feed the west quadrant of any gale that forms in this trough, and that would take aim at Hawaii primarily. So maybe then the trough starts getting, look at how deep it's pinched. That is not a lot of space between the west side and the east side, but still maybe some low pressure could form there. Again, continuing, wow, look at that into Friday and Saturday, and then it starts getting cut off from the main flow. Where is the main flow of energy? It kind of is here. It's kind of warbling around, but nothing too extreme. And there we are, 180 hours out. Now, the interesting part here is that there is supposed to be this persistent trough right here in the Gulf of Alaska. The good news about that is maybe it'll cut down the high pressure system. Maybe that will help alleviate northwest winds. Maybe that'll help bring water temperatures up a little bit. But what it'll also do is eliminate any wind swell development along the California coast, and probably east wind swell for Hawaii as well. So let's go take a look at the surface and see if that bears out. Here we are, surface level pressure, surface level winds. High pressure, 1032 millibars in the northeastern Gulf. Low pressure inland creates a pressure gradient, and no big surprise, 30-knot north winds just blowing solid along Cape Mendocino, and for that part, almost all of northern California, generating wind swell. But notice no real trades pushing into Hawaii. We'll get into that in a minute when we start talking about wind swell potential. Right now, we know there's a trough supposed to be setting up here So we're looking, there you go. Sure enough, as we get into Tuesday, little low pressure, let's go back. Little low pressure system, supposedly with 50 knot winds over 1 pixel of the image, and quickly fading out, but maybe that'll get a little bit of traction. And then another low comes in right behind it, because we know the trough starts getting deeper as we get into Wednesday. So another batch at 30, 35 knot winds. Notice I cut off low over here, but all this fetch is aimed at the Kuril Islands, so no hope there. And then we know the trough is supposed to continue, but it's not a whole lot going on. Because it's so pinched, I suspect that low pressure is having a hard time will have a hard time getting organized. Yeah, 25 knot wind, sort of aimed at Hawaii. Good for maybe some wind swell. Now look at this. As we get into Saturday, this is a long ways out, and I'm purposely not looking over here. We're going to talk about that in a minute. But as we get into Sunday, supposedly a gale is to develop in that trough, that broad trough there, 30, 35 knot northwest winds, maybe even more as we get into 180 hours out. So, kind of interesting. Now, you see here, big tropical system. We're going to go back in time. Let's just see where that thing starts off. We're into, let's say, maybe Wednesday time frame. Now, what is going on? One, we never believe the GFS model concerning tropical systems like 4 days out in advance. But what is happening, we'll get more into this later, is the active phase of the MJO is building quite strong here. The first westerly wind burst in a long, long time is forecast developing. You can actually see it on the surface level charts here on the equator. Kelvin wave generation area is right in this area right here. You see easterly winds, and then they start slacking off, and they actually turn westerly here. Westerly wind bursts help feed tropical development. They also impart energy to the jet stream. So it's no big surprise that, theoretically at least, as the active phase builds in this area, some sort of tropical system theoretically could develop, and this would be off the Philippines. Water temperatures are quite warm over in the far west Pacific because of La Nina, stronger than normal high pressure, increasing trades, taking all the warm water over the Pacific, pushing it into this area. You need warm water to get evaporation. You need a relatively non-shear environment, that is, winds not blowing hard, hard one way in the lower atmosphere and hard the opposite direction up in the upper atmosphere, because a hurricane is effectively like a chimney and it's venting heat out up into the upper atmosphere. If there's shear, it basically closes the chimney and a hurricane can't form. So, theoretically, the models are showing all sorts of interesting stuff. Whether that happens, yet to be seen, but the fundamentals, the active phase of the MJO, warm water, all that sort of stuff is in place, and so this is a possibility. But back to the task at hand. Seas, surf. All right, so we know there's, where are we? We're at Monday. We're looking right up here. Monday, Tuesday, there's that little fetch. It produces, 50 knot winds for 6 hours over, 50 square miles or something. Get you 19-foot seas. No big deal. All right, that probably wouldn't even be noticeable swell. And then a little bit more on Wednesday, but again, that kind of fading out. And we're just looking for anything aimed at Hawaii or the U.S. West Coast. And then we know there's another low forecast out in the Sunday time frame here. Notice the fetch is kind of ill-formed, and so the seas aren't particularly well organized, but maybe some wind swell for Hawaii and the U.S. West Coast if all this comes together as forecast a week from now. Odds quite low at this point in time. But looking down south, there is some good news. When was this? A week ago, Sunday, a little gale formed under New Zealand. 31-foot seas, up 32 foot. The highest seas over this entire image, 32 feet, and there's the position. Falling southeast, and then another one. That was sort of a primer, and then the main system developed with 36-foot seas. Now, this is not a good, well-organized, big system by any stretch of the imagination. And it was falling southeast, so it was small. There we go, and another, 37, 35-foot seas. fading from there as we got into Wednesday. So we'll say 3 days of fetch in this area. Theoretically, some small swell is radiating north towards Hawaii. I think it arrives midweek, and then maybe towards later in the week for California. I mean, we're talking small swell, barely 2 feet at 16 or 17 seconds. So chest-high surf or something like that. Maybe top spots will get a little bit better. Anyway, and after that, things pretty much faded out. Don't look at Tasmania. That has already happened. That was, what was that, yesterday? Hindcaster look at it. But let's go take a look at the forecast now. So we know there's little swell in the water. We're looking for something else. Now, a small gale is forecast on Tuesday in the far southeast Pacific. Was at 33, building to 37 foot midday Tuesday, and up to 38 feet Tuesday night. And the cutoff is about, for Southern California, is about 118 west and 38 feet again. So theoretically, small, very south-angled swell could result, and we're within a decent, within 72 hours here. So yeah, theoretically, swell could result, radiating north about a week later for California, and of course down into South and Central America. And then another system is forecast behind that. Nothing huge, seas in the 28-foot range, maybe 30 feet as we get into Thursday. And yeah, 31 feet, something like that. So theoretically, 2 small southern hemiswells could result, and then they push out of the Southern California swell window. Focused well, though, on Peru and Chile. And then we go out beyond that, looking for anything out a week and nothing else. So 1 swell, theoretically, on the way. Small is the operative word. And then maybe 2 other swells behind that, focused on the U.S. mainland, nothing for Hawaii, and then certainly down into Central and South America. So next up, looking at wind swell. We're in good shape in terms of wind swell right now. There was actually sizable waves in we'll call it the San Francisco Bay Area today. I mean, nothing huge, but overhead surf at top spots, raw, pure wind swell, but generated by 30-knot winds off of most of the Northern California coast. As we get into Monday, 30 to 35 knot north winds continuing off of Cape Mendocino. More wind swell likely. Notice really nothing for Hawaii. No fetch over here. That's why we're not talking about it. So we get into Tuesday. Fetch settles down a little bit. 25 knot winds. You can get a zoomed in view of what's going on in the Gulf, but we're focusing on wind swell. And then up to 30 knots midday Tuesday. And then at some point as low pressure builds here, high pressure will start slacking off. You can see that on Wednesday, 20, maybe 25 knot winds, good for some little wind swell. And then as the low starts building in the southern Gulf of Alaska, by Thursday, all wind swell pretty much disappears. No pressure gradient, nothing to force anything. Then we get into Sunday, and maybe, look at this, a little bit of high pressure is supposed to theoretically set up off California, but 15 knot winds off of, we'll call it the Bay Area down into Central California, isn't going to do much for wind swell production. This would be the main source of swell if that happens. And what do we got? We got one more frame there. So for the most part, wind swell for the first part of the week, then dying out. Then we focus on the Gulf of Alaska and hope for some, just eyeballing it anywhere from 11 to maybe 13 second period. We'll call it wind swell for Hawaii and the U.S. West Coast with luck if the models aren't lying to us. Quick look at precipitation potential. We'll just cut right to the chase. No precip is scheduled for California, but this little backdoor low is forecast developing over Tahoe and the Sierra. Maybe, there you go, a little drop of snow in the Wednesday time frame, and that pretty much fades out. At some point here, temperatures are going to get warm enough that there's just literally going to be no hope, for snow at all, and it'll be rain in the Sierra. Let's go see what effect and how much snow that actually totals up to. We're just looking at Squaw Valley. What are we talking about? 2 inches, maybe 3 inches, something like that. So, and all on the morning of the 14th. So, and what's the snow level at? Okay, it drops to about 7,000 feet. So maybe up top, a dusting of snow at best. But notice these, so this is the base of Squaw, 6,000 feet. This is the top of Squaw, 9,000 feet. And that's pretty much good for the entire Lake Tahoe region. You notice the gray is the slush line and white is where real snow starts. We're up to, what is that, 12,000 feet by the morning of the 17th, and pretty much holding somewhere between 11 and 12,000 feet after that. I mean, no big surprise given the way the year's going. It's going to be an early summer more than likely. Snow melt starting early if it hasn't started already. And this might be the last little hurrah for any sense of anything that resembles frozen precipitation in the Sierra. All right, let's go take a look at long-term. What's going on with the Madden-Julian Oscillation, and of course the El Nino Southern Oscillation. So first off, we're looking for signs of the active phase of the MJO, the Madden-Julian Oscillation. It's that periodic weather oscillation. Typically, there's an active and an inactive phase. They are both present, one on one side of the globe, one on the other side. On the equator only, they move from west to east. So this is the West Pacific here. This is the East Pacific here. So both the active and inactive phase move from west to east. Typically, if the active phase is in the is over the Pacific, the inactive phase is on the other side of the planet, and vice versa. It takes about 4 to 5 weeks for the active phase to make its way across the Pacific, and then typically followed by the inactive phase, and it has about the same duration to make its trip across the Pacific. All right, so what we're looking at here is data from the TAO buoy array, series of buoys strung across the equator. This is the equator right here, East Pacific. The international date line right there, that is New Guinea. This is the far West Pacific. We're looking at the arrows. This is data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino, but they also give you a pretty good sense of what's going on with the MJO. The arrows, the longer the arrows, the stronger the winds and the wind direction. So east winds, trades, pretty strong in the East Pacific, pretty, we'll say moderate strong over the Central Pacific, moderate strong over the West Pacific. But it's not the absolute wind, and this is like average wind speeds. It's the anomalies, differences from normal for this time of year. Yeah, east winds are pretty strong, but you know what? Looking at this, that's almost normal. They're just a hair bit stronger out of the east because there's these little baby arrows, right? And we're only looking 5 degrees north and south of the equator here. So maybe a little bit stronger than normal, but you see that there? It looks like they're strong, but for this time of year, there's no real arrows in the Central Pacific, so that's pretty much normal. And what's even more important is over here in the far West Pacific, the Kelvin wave generation area from 170 west to 135 east, 5 degrees north and south of the equator. Draw a box in your mind right there. You can see here, at least where there is data. There's no data over here. All these buoys are down. But you can see the trades are not blowing all that much stronger than normal. And that's a good sign because we've been in La Nina all winter. Trades have just been raging out of the east, across the whole Pacific for that matter, causing massive upwelling, cold water temperatures. Cold water temperatures mean no evaporation. That means high pressure. That means no precip into California. And I don't know what the exact number is, but I think as of right now, by the end of the rainy season, we're in the 37 to 40% of normal precipitation and snowfall amounts, something like that, give or take a little bit. Better up north, far less down south, like in the southern Sierra. Anyway, winds almost normal. That's a good sign. Now the forecast. Now you'll notice April 6th. This is stale data, and we talked to Michael Ventris, the guy that runs this website, and he says the server that he's running on is basically shut down. He doesn't know whether it's going to come back or not. He doesn't know whether any of this data will be here, but we have other ways of getting to it. But just a quick look here and sort of maybe a farewell for this one graphic. You see, so the date line is right here. Whole planet on one chart, right? Okay, today's, well, actually we're down here somewhere, but you get the general idea. The blues are easterly anomalies. The reds, yellows, westerly anomalies, and pretty strong westerly anomalies. Oh, and the Kelvin wave generation area. The area in the West Pacific starts about 135 east, goes right up here to 170 west right here. This is the key area we're interested in. And what you see is westerly anomalies building in the far west Pacific in the Kelvin wave generation area, and strong easterly anomalies in the far east Pacific starting to get displaced by these westerly anomalies. Let's dig in a little deeper. So let's go out a little bit further. All right, now these are not winds. This is outgoing long-wave radiation, basically cloud cover. But that it's good enough. It tells you what's going on. So this is, there's South America, Central America, the equator right there. The blues are more cloud cover, less sunlight reflectivity than normal. The oranges here in the Indian Ocean, there's Australia, New Guinea, Bali would be right about there. This is more sunlight bouncing off the ocean surface, more sunlight reflectivity, meaning high pressure, the inactive phase of the MJO. We want the active phase, and it's right where it should be, in the Kelvin wave generation area today, this per the statistic model. And according to the model, 5 days from now, it holds. 10 days from now, it weakens. And then 15 days from now, the inactive phase shows up and takes over the Kelvin wave generation area. Now that's interesting, but the dynamic model paints a much different picture, and we'll see if we can get the last, there we go. Okay, active phase in control in the Kelvin wave generation area, 5 days from now, 10 days from now, and if anything, building stronger 15 days from now, while the inactive phase gets locked in the Indian Ocean. This is interesting, and this is key. If this develops instead of this, that would suggest that we have some bias that's going to start favoring the Pacific Ocean for low pressure development and westerly anomalies, and that's exactly what we want to try to get La Nina out of here. Phase diagram charts, another way of looking at the MJO, all right? So what are we looking at? Well, the equator, the MJO moves from west to east, from the Indian Ocean, over the maritime continent, over the West Pacific, East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. The heavy dot is where the active phase is, exactly where we want it, right smack in the West Pacific. The further the dot is away from the circle, the stronger it is. So a modest active phase of the MJO in the West Pacific today. The 2-week forecast, according to the statistic model, has it basically crashing, getting weak, and moving over North Africa 2 weeks from now. But the dynamic model has it sort of noodling around in the West Pacific, and then only the last 2 or 3 days of the 15-day run moving over to, we'll say, the East Pacific. So clearly this is the more favored outcome, because the longer the active phase sits over the Kelvin wave generation area, and the stronger it is, the more west anomalies it produces, the more energy it transports into the jet stream to feed the storm track, both north and southern hemisphere, and also the more these westerly anomalies have the potential to generate a Kelvin wave. That is, take warm water from the West Pacific and start moving it towards the East Pacific. And that's exactly what we want, to sort of break down La Nina, break down enhanced trades, and set up a more normal regime over the equatorial Pacific. The upper level model, and we believe this is a statistic model. Okay, so what are we looking at? There's South America, Central America, New Guinea, Australia, Kelvin wave generation area right here. The greens are, it's another component of MJO. There's the east-west wind component. There's the cloud cover component. And if you have clouds, you have precipitation. That's what the greens is. Areas favorable for precipitation, so one can roughly say that's the active phase of the MJO. Active phase today, right where it needs to be in the Kelvin wave generation area. But according to this, and again, we say this is the statistic model. The statistic model says, oh, the active phase is to move out of here and be over, moving into, it's on the equator, moving into Ecuador by May 1st, with the orange dry air moving in, the inactive phase traversing the Pacific through about, the 11th of May, and then another active phase setting up after that. And this inactive phase stronger than either of the two active phases. You can kind of eyeball that right there. So this is the sort of hey, we still think we're in La Nina kind of mode. But as you see in some of the other models, they have a different opinion. Here's the CFS model. It goes out a month. All right, whole planet on one chart again. This is east-west wind anomalies. The blues are the, we'll call the inactive phase, the MJO, the La Nina sort of thing. In fact, okay, and the reds, westerly anomalies. That's what we want. Kelvin wave generation area starts at 135 east in the far west Pacific, goes to about 170 west right there. All right, so in early March, this dotted contour here, that is the inactive phase of the MJO, traveling from west to east on the equator. It's already out of the Kelvin wave generation area. This solid contour is the active phase of the MJO, moving from the Indian Ocean and today in the far west Pacific, in the Kelvin wave generation area, and generating westerly anomalies. And for the entire next month, it is forecast to just sit over the Kelvin wave generation area and produce not super strong, but we'll say moderate to almost strong westerly anomalies. This is a significant change because we have not had an active phase of the MJO of any strength for literally a year now. And that is not unexpected when you have La Nina in play. But now that the active phase is sort of waking up, this could be a clear sign that La Nina is on its way out the door. And then there's the 3-month CFS model, all right? Past performance is down here. The forecast is at the top. Whole planet on one chart. Kelvin wave generation area starts right along here, far west Pacific, to right about here. And look at the difference here. So this was January. The blues are easterly anomalies. Easterly anomalies, a weak, very weak little Kelvin wave occurred in February, producing some weak westerly anomalies, these yellows, and right back to easterly anomalies. But look where we're at now. And you just look up here, and pretty much for the entire duration for the next 3 months, all we see is westerly anomalies, save a little bit right there and a little bit right there. That is a significant change. And even this little guy here, this was an active phase of the MJO. It has produced a Kelvin wave that is in flight right now. If this produced a Kelvin wave, what's this going to do? And this lasted for, what, from January 29th to about 5 weeks. This one is supposed to go pretty much for 3 months. Significant change in the balance of warm water in the Pacific would be the likely outcome if you believe this model. Again, we don't hardly believe a model a week out, much less 3 months. But okay, let's validate what we just assumed. So the solid red contour is the active phase of the MJO. We saw that. Yes, okay, and there's the westerly wind anomalies. Dotted contour, inactive phase of the MJO. This already happened. Here is our beginning of the active phase, just about filling the Kelvin wave generation area right now, and expected to last in the Kelvin wave generation area into mid-May, maybe May 20th. That's pretty good, with solid westerly anomalies in control, followed by an inactive phase. But even during this inactive phase, notice westerly anomalies in control. Something's going on there. And then another strong active phase forecast after that with strong westerly anomalies. So what could be? Well, all you that watch this already know the deal. Here is the high pressure, low pressure bias. All right. So the dotted contour is the high pressure bias. This is like, it is La Nina effectively. Centered right over the date line where it's been with 1, 2, 3, 4 contour lines. And it's been that way all winter. Well, notice by tomorrow, the 4th contour line is supposed to fade out. By the first week of May, the 3rd contour line fades out. By mid-May, mid to late May, the 2nd contour line is gone. And then as you get into the first week of June, the last remaining contour line literally moves out of the Kelvin wave generation area completely. Now, flip side, over in the Indian Ocean, this solid contour, low pressure bias, this is El Nino, if you will, or the thing that makes El Nino. Notice it's starting to slide to the east, into the Pacific, into the Kelvin wave generation area, and almost fills it right there. That's about, 175 east, almost filling the Kelvin wave generation area. We'll say starting sometime in May, something like that, maybe early June. So a significant shift. We move from the dateline area being dominated by high pressure this past winter to being dominated by low pressure and westerly anomalies versus easterly anomalies. Low pressure and westerly anomalies as we get into the beginning of summer and move into the core of summer. If all this happens, that would definitely indicate the end of La Nina. All right, so let's go see what's actually going on. We're going to do a little tour. We're not looking so much for forecasts. What's actually happening on, in the ocean, on the ocean surface, and above the ocean today. All right, West Pacific here, East Pacific here. Data from the TAO buoy array. This is a temperature profile of the ocean, the equatorial Pacific. East Pacific here, West Pacific here. These are the anchor lines on the TAA buoy arrays. The X's are sensors. They collect data. It's all transferred to a central processing facility. Apply a model to fill in the gaps. And what you get is you see the warmest waters in the far West Pacific. It was limited to it never made it the 28 degree isotherm right here. That's 28 degrees centigrade. That's warm water. All winter long never made it anywhere east of 165 east. Today, even last week, I think it was somewhere around 175 east. Today, it's on the dateline and almost starting to move east to there. The 24 degree isotherm was all winter long. It made it to maybe 140 west. Now it's pushing the whole way into Ecuador, much deeper, much more sense of mass of warm water starting to shift off to the east, taking over the entire equatorial Pacific, at least at depth. But it's not the actual temperatures. Again, it's the differences from normal from this time of year. And you can see that quite clearly. This is like a river of warm water, not superheated, 1 degree centigrade. That's like, 1.5, a little bit more degrees Fahrenheit. But from the West Pacific, moving the whole way into almost Ecuador, starting to, according to this model, reach the surface in the far East Pacific. All winter long, we have had much colder than normal water right here. That's all gone now. Warm water in control. We have yet another model. Here you go. A little bit higher res model. A little bit more conservative. It says the warm water has not reached the East Pacific yet. It also is about a week behind. Okay, but it says it's at about 105 west. So we'll figure out where that is. But look at that. Almost reaching the surface down about, what is that? Maybe 30 meters. That'd be about 90 feet below the surface. But you see clearly warm water on the move. This was generated, this warm water started flowing, and it's not on the surface, it's under the surface. This is a classic Kelvin wave signature generated by the active phase of the MJO in February. Remember, that active phase produced weak west anomalies, but there was piles of warm water here. Boom, as soon as the trades let up a little bit, boom, it just started flowing off to the east. It's going to take 3 months to make it to here. So we'll say mid-February to March, April, maybe in May somewhere, it'll reach Ecuador. And this is the last of the cold water of La Nina. This approaching warm water is acting like a bulldozer, just squeezing this cold water to the surface. So you'll see on the surface charts, water temperatures are still cooler, but that's actually a good thing because they're getting pushed out by warm water that's coming, and as soon as it reaches the East Pacific, that's going to be the death nail on La Nina. Sea surface height, we've talked about this before. So there's Chile, Peru, the Galapagos right there. That's the equator. That's the dateline. Central America, Hawaii right there. This is the height of the ocean surface from Jason 3 satellite. So the satellite strips off all the waves, the wind waves, the tides, and just, the sphere of the Earth, including the ocean, is it bulging or depressed in any area? And what we're seeing is all winter long, it's been below normal, 15 centimeters below normal. Cold water contracts, creates a divot on the ocean surface. Strong trades blowing in this area will decrease the height of the ocean surface here and make it higher over here, trades blowing this direction. So you see, even today, piles of warm water, though it's inferred warm water in this area, but you get the sense there's a ton of positive anomalies pushing here. What would we say? 110, 105 is where the leading edge of the Kelvin wave is, right about there in that one model. That makes sense. So this helps confirm what we saw in the other images. Upper ocean heat anomalies. Differences from normal temperature. West Pacific here, East Pacific here. Last April, this was the beginning of La Nina. Blues are colder than normal water temperatures. A little bit of a Kelvin wave back in July tried to push east, didn't really make it, and then La Nina just took hold by Halloween. Very cold water, just taking over the entire East Pacific, while, because the trades were nuking, blowing hard, taking all warm water, and it just started building up and up and up in February here in the far West Pacific. We got that one little weak active phase of the MJO, and that was enough to unleash a torrent of warm water pushing east. You can see on this image it says it's to about 110 west. We think it's really about 105, and still has about another month to go to make it to Ecuador. So things looking much different, with much better potential for surf and precipitation for next fall, given what we're seeing happening right now, assuming the pattern continues. Surface water temperature anomalies. Differences from normal for this time of year. All right, South America down here. That's Chile, Peru, Ecuador, Central America. Okay, what jumps out? Right here. Much colder than normal water along Peru, and not along the coast of Ecuador, off of Ecuador. There's the Galapagos right there. Making it to the Galapagos. And then things kind of really moderate. Yes, trades are still blowing. There's some upwelling going on, but this is much warmer than what it's been. And this thing here, this secondary ball that's not on the equator, this was much more defined, has been for months now, but it's kind of not doing so great lately, which is a good thing. We want warm water. So this ultra cold water here that's upwelling to the surface, again, we believe that is because the Kelvin wave 105 west is somewhere right here under the equator. So warm water under the surface, all here, pushing to here, taking the last of the cold water, bleeding it, squeezing it up to the surface, and that's why we have this cold signature here. But that should be fading. I'll give it another couple of weeks. Sea surface temperature trend. Now, a while ago we saw much cold, that cold water that was upwelling to the surface. Well, it's not getting any colder. If anything, you can see right here, things are warming here. Right around the Galapagos, it's still cold, but a little bit of warming off Ecuador, a little bit of warming off here west of there. But overall, kind of temperatures are neutral. When the Kelvin wave erupts, we would expect to see this area right in here start getting pretty bright red, and pretty quickly, like literally in a 5-day period, we'll go from something that looks like this to a lot more red over in this entire area. And when that happens, temperatures start increasing, you get more evaporation, that starts feeding the jet stream. Now, it's not going to be instantaneous, but it sets the stage to start the ocean changes, and then the atmosphere above it changes. But this thing has to go on for months, 3, 4, 5 months, before the North Pacific or the South Pacific jet stream really goes, hey, something's going on. It wakes up and it tries to reconfigure itself. And it's not just right here. It has to do it the whole way around the planet. So it's a big ship. It takes a lot to get it to change direction. Quick look at the upper, just sort of the high-level view. Yes, this is still La Nina, cold water over the equator, right? And it's everything's about the equator, 5 degrees north and south of the equator. The Kelvin wave generation area over here is where we generate Kelvin waves. Kelvin waves radiate across the Pacific under the ocean surface. They erupt over here. That warm water gets caught by the trades and then moves over into this area. And all this, the summation of all this, is what affects the jet stream. But particularly when you get the active phase over here, that feeds energy to the jet stream. It creates Kelvin waves. When the Kelvin waves are up here, that creates warm water here. That sucks basically the jet stream further south and provides precipitation potential into California. Not all this is locked down and certain, but that's the general trend. Okay, that's why we're so focused on what's going on here in the West Pacific with the active phase of the MJO, because it sets in motion something that 3 months later can affect the East Pacific significantly. And if you have multiple Kelvin waves in a row, we have one in flight, we have another active phase of the MJO setting up over the West Pacific right now. That's theoretically 2 Kelvin waves. Multiple Kelvin waves can help kick off El Nino. Sea surface temperature anomaly history. All right, the Nino 1.2 region is the area right there by the Galapagos and Ecuador. Temperatures since March have been plummeting, but why is that? Well, we know why. Massive Kelvin wave pushing east, squeezing cold water to the surface. That explains this big drop. There really hadn't been any massive easterly anomalies, no strong inactive phase of the MJO. So this is all actually kind of good news. It tells us that the active phase of the MJO in February produced a Kelvin wave, and that Kelvin wave is in flight, and it's squeezing cold water to the surface. The official El Nino monitoring region, this is from an area south of California on the equator, about out to the dateline. Temperatures slowly and steadily, so this is clearly La Nina range, 0.5 degree for 5 consecutive months. That was La Nina, but notice today we're at 1/4 degree, 255 thousandths of a degree below normal, and you kind of get the sense that it's rocking around, and all we need is a Kelvin wave or two to push it up into the neutral or better territory, and if it sits there long enough, then that's the end of La Nina in the atmosphere. All right, so what's going on in the atmosphere? Does the atmosphere sense that anything is happening? The ocean's doing its thing. I mean, all this action is really below the ocean's surface right now. The ocean is still colder than normal, but does the atmosphere sense that anything is going on? Because there have been signals in the West Pacific. Well, we look at the difference in pressure between Darwin, Australia, and Tahiti. Tahiti's in the Pacific, Darwin's in sort of the Indian Ocean. And when pressure is lower in Tahiti, this index starts going negative. Okay, when the active phase of the MJO is over Tahiti, the West Pacific, the index goes negative. When the inactive phase or La Nina is in play, it goes positive. Today's number, plus 9.08. Okay, and what's been happening? We just sort of look back over the month. Well, it's been kind of all over the place. Kind of a noisy number. Kind of hard to tell what's going on. So we go out, we average it out over 30 days. Today, the value is plus 1.52. So just almost neutral. We were down in negatives, just barely negative there for at one point. We were also positive. So this is sort of more the active-inactive phase of the MJO indicator, and this currently is saying a neutral MJO. I mean, almost dead neutral. The 90-day average is the La Nina El Nino indicator. Today, still positive, 6.74, but we were up 12.39. I think we were up to plus 15 at one point. Definitely still falling. This suggests that the atmosphere senses that La Nina is at least taking a break, but we know from looking subsurface, we know from looking at the models that I think something a lot bigger than a break is forecast. In fact, here's the 30-day SOI graphed out, so you can see back in 2019 we thought we were in El Nino, negative numbers, very weak El Nino, and then April of 2020, that's when La Nina started. You can see the index just started rising. The downward spikes are the active phase of the MJO, and then the upward spikes are the inactive phase. But since January, it's just been steadily dropping. We're at effectively dead neutral today, but what we want to see is this go down even deeper. We think the active phase is building over the West Pacific today, over Tahiti, and that would therefore we would expect this to start dropping negative, and that's exactly what we need long term to dislodge La Nina. And then finally, the sea surface temperature anomaly forecast for the Nino 3.4 region, the official El Nino monitoring region. So where are we? We're in, well, this would be mid-April. We're not quite there. We're here. And sea surface temperatures, according to this, are 0.2 degree below normal. That's about right. Forecast to rise to neutral, if not build to above neutral as we get into June. Now here's the real head scratcher. This model suggests after that, boom, just a return to core La Nina as we get into October and into the fall. Now the interesting part about this is every other model for the most part says that's not happening. We are in the spring unpredictability barrier this time from like March into about the end of May. The models have a real hard time knowing what's going to happen because the signals aren't obvious. That's why we're doing all this digging. We're looking at Kelvin waves. We're looking at active phases of the MJO, trying to put all the pieces together and see if we can outsmart the model. We think as of right now that this is probably a red herring. The temperatures will not drop down to about, 0.85 degrees below normal as we get into the fall of this year. I mean, that would put us right back into La Nina. Everything we're seeing, assuming the models are somewhat correct, is hovering somewhere around neutral with the atmosphere pushing that direction too. But for now, I mean, this was looking better last week. Now we're back into a hole. So this is, again, part of the nail biter syndrome. We'll just have to see how it plays out. All right, for right now, wind swell's in the water. Southern hemiswell is radiating north, expected into Hawaii. I think it was midweek, and to Southern California at the end of this week. Nothing huge. Two small southern hemi gales, we'll call them, are forecast in the southeast Pacific later this week. That might help produce some more swell beyond that. Nothing huge, but something rideable. Also, a small, we'll call it low pressure system forecast for the Gulf of Alaska. That might produce some swell. The wind swell machine looks like it's going to die down quite a bit as we get later into the week. That's good, though. I mean, it is the winds that have been, and the wind swell that has been creating the upwelling, driving temperatures so cold. Please give us a break. Please let it warm up just a little bit. Make it at least feel like we're not in, that there aren't icebergs out there. We'll see how that all plays out. But maybe that would be a good sign. Longer term beyond that, certainly, active phase of the MJO looks like it's pretty much locked and loaded for the next couple of weeks. How long it lasts, unknown. Will it produce another Kelvin wave? Unknown. But for sure, we have one Kelvin wave clearly in flight, clearly going to take a notch out of La Nina. Hopefully, a second one and maybe a third one beyond that will completely signal the demise of La Nina, at least get us back to a normal state as we get into the late fall period, and then we'll be back to normal as we get into the fall season. All right, if you enjoyed the video, give us, there we go, a thumbs up. If you haven't subscribed, please subscribe. If you don't want to subscribe, that's okay. The link to the video is posted at the top of every page of Stormsurf.com. That's where most of this data can be found. Stormsurf.com. Sit there, monitor along, check buoys, check buoy temperatures, the wave models, the wind models, all that kind of stuff. And then test your knowledge at the end of the week when we post this video. We typically do it on Sundays. All right. Well, that's it for this week. Thank you for watching. We're going to do it again next week. Same time, same channel. Stay safe, get some waves, and we'll see you next Sunday. Thanks for watching.